In the 90s, we all had one common enemy. You are peacefully hunting ducks, having the time of your life. Then you miss a few shots and this guy lets you have it. We wanted revenge. We wanted justice. But the game never gave it to us. We need a different kind of solution. If we couldn't handle him, maybe we should call in a professional. Maybe we went too far, but let's see where the rabbit hole goes. The build is, I'm using C++ and a few custom drawing routines. You can use my engine, SDL, or whatever you prefer. You just need something that can push draw images and text. First up, the HUD. The default approach is to search for sprites online. You could even rip graphics directly from YouTube, take a screenshot, clean up it in Canva, or even clone stamp it in Paint.net. Throw that on screen and voila! The original Doom resolution was 320 x 200, but I've rescaled everything to work at 640 x 480. But stop! We don't need to scrub through YouTube videos, screenshots, not even sprites on the internet. If you own the original game, or even the shareware version, we have a much better way. Doom-like games have assets in WAD files. Grab a tool like Slate, open up doom1.wad, and you are in. It is a massive rabbit hole of assets, so go ahead. Investigate everything, sow in the nostalgia, and come back to the video when you are done. I'll wait. Since we are already digging through the WAD, let's grab the shotgun. We could just use a static image and call it a day, but I want to get straight to the good stuff. Animation. The shotgun has 4 frames for shooting and reloading. Interestingly, the muzzle flash is actually a separate sprite. Developers did this decades ago to save precious memory. Good old times, right? For simplicity in our game, I'm going to composite these frames together and baking the muzzle flash directly onto the gun sprites. Before we jump into the code, we need one last thing. The background. Duck Hunt sadly doesn't use WAD files. Surprise, surprise. And I don't feel like hex editing an NES ROM today. So we are going with the Google It method. I rescaled the background to match our 640 width, but the word of warning, be careful. When resizing pixel art, you must use nearest neighbor interpolation. If you don't, your pixels will turn into a blurry mess and nobody wants that. Let's write some C++. First, we load our assets. Then we render the scene layer by layer. Background, HUD, and finally the text. Notice the double draw clause for the text? That's how we get that retro drop shadow effect. Draw it black, then draw it red just slightly offset. For the shotgun logic, it's all about the timing. I set up a vector containing the animation sequence 0, 1, 2, 3 and back down again. When I click, we flag the gun to shoot and the engine steps through these frames based on an elapsed timer. Instead of loading separate images, I'm using draw partial sprite to grab the 238 by 350 pixel rectangle we need from the cheat. I kept ×2 explicitly mentioned to don't forget I'm using a higher resolution than the original. You can do whatever you want. If you want to use different technique because your engine library doesn't support partial image drawing, feel free to do so. If it works for you, that is what matters. Compile, run, and let's move on. I want to add a crosshair. Not that the original game had anything like that, but we need it for our concept. I put something together, keeping it symmetric and simple. Implementation is straightforward. We load the sprite, and in the update loop, we draw it at the mouse position. One small detail. If I just used getMouseX, the crosshair would hang off the bottom right of the cursor. So I'm subtracting 20 pixels from both X and Y coordinates to shift the sprite's center perfectly over the mouse. I also tweaked the shotgun values. I adjusted the frame indices to 1, 2, 3 to skip the idle during firing and slow the anim speed down to 0.12. It gives the gun a bit more heft. I'm going to tweak the crosshair a bit. Actually, you might see a few different versions pop up through the video. Now, it's time to get the ducks. The original game had a few different variants, but I'll stick with this one. I've prepared a sprite sheet with the duck flying both left and right. Why? Because my engine doesn't support automatic image mirroring. And yes, I know, just minutes ago I was praising the old school developers for their clever tricks to save memory, and here I'm doubling my asset size just to avoid writing a flip function. But hey, just being modern. Before we let this bird fly, let's clean up our workspace. First, I move all text rendering into its own function called drawHat. It keeps the main update loop clean and readable. Second, I added some boundary logic for the crosshair. By clamping the mouse coordinates with std_main and max, the reticle now stays strictly inside the window borders. No more losing your aim of screen and crashing. Finally, the target. I've loaded the sprite and rendered it at a fixed coordinate for now, just to check the scaling and transparency. Looks good. Now we need to make the duck flap its wing. The math here is exactly the same as the gun animation. Instead of writing the same if timer is higher than speed all over again, let's make it generic. I moved all the timer logic into a new animated sprite struct. Now, instead of fancy lines of if statements clogging up our update loop, the shooting logic is just this. Shoot is equal draw animated sprite. Here is the cool part. The function returns true while the animation is running and false when it finishes. So it effectively resets the shoot trigger automatically. Inside the function, we handle the frame timing and the frozen state. It works perfectly for the shotgun. However, if you have a keen eye, you'll see I'm still hard-coding the sprite size to the gun's dimensions. That works for now, but we'll need to make that dynamic before the duck can use it. I updated the animated sprite struct to include frame size. Now our drawing function is truly generic. It uses the object's actual dimensions instead of hard-coding the shotgun size. I also added show cursor for false to hide the Windows pointer. It was ruining the immersion. For the hit detection, I'm using standard AABB collision, axis aligned bounding box. It's a simple check. Is the mouse cursor inside the rectangle defined by the duck's position and size? To visualize this, I'm drawing a debug rectangle around the duck. It defaults to white, but inside the update loop, if we click and those coordinates overlap, the box turns red. That's a confirmed hit. It is a time for the dog. Because we spent that extra time building a solid foundation with our wrapper, adding a new character is incredibly straightforward. I took the frames of his laugh, stitched them together, and he is ready to go. But we have a visual problem. If you just draw him now, he floats on the top of the grass. We need some depth. If you look closely at the original duck hunt, it actually simulates layers. Even the ducks fly behind the trees and bushes. To replicate this, I performed some surgery on our background image. We need to separate it into two layers, the static sky and the foreground footage. By rendering the sky, then the dog, and then the rest, we can make him pop up from behind cover, just like we remember. In the onUserUpdate function, we first clear the entire screen with the specific color, 109, 182, 255. That is the exact RGB value for the NES Sky Blue. Next, we draw the dog. Finally, we draw the BCG sprite, which is now just the grass and the tree with transparent top over the dog. By sandwiching the dog between the solid color fill and the foreground sprite, we get instant depth. He isn't floating anymore, he's hiding. It's a simple trick, but it sells the illusion perfectly. He's right there, laughing at us from behind the bushes. Time to add movement. I'm going to update the duck's position every frame by adding a simple speed vector. To keep it inside our player area, I'll add boundary checks. If it hits a wall, we invert the velocity. Basically, I'm giving this duck Arkanoid physics, or DVD logo physics. It's not technically accurate to the original duck hunt, but it's simple, effective, and feels dynamic enough for what we need. I set up a simple velocity vector back. Every 8 milliseconds, we add this vector to the duck's position. When the duck hits the left wall, we invert the x velocity to make it bounce. But we also have to manually swap the animation frames to the right-facing set. When it hits the right wall, we swap back to 0.2. It's brute force, but it gets the job done. Finally, pay attention to the rendering order in onUserUpdate. Clear screen, which is our sky, dog, duck, and grass. By drawing the duck before the grass, it can fly behind the tree trunk, just like in the original game. We have ignored him long enough. It is time to work on the dog. I needed a death animation. I could have drawn one, but while digging through the Doom sprites, I noticed something interesting. The imp death animation. Look at the colors. The brownish sludge is almost the exact same shade as our laughing friend. So I ripped the frames of the imp exploding, stitched them together, and prepared them for the dog. For anyone who has endured that 8-bit laugh for 30 years, This is going to be incredibly satisfying. I introduced a new sprite object called docS, short for splatter, to control it. I use a simple boolean flag, doc_a, which is doc alive. By default, it is true, but the moment I click the mouse button, I'm flipping it to false. Now look at the update loop. If doc_a is false, we stop drawing the doc and start drawing the explosion. It is common in game dev to draw an asset or object, and if something happens, replace it with something else. Things are not necessarily connected within a single instance. Crucial detail: we don't want the explosion to loop forever. Inside the check, I added a line that says, if the animation finishes, lock the sprite to frame 7. This ensures he turns into a pile and stays a pile. I also took a second to polish the hat, adding in the ammo counters for authentic Doom look. Just static for now. The dog is toast. Now, back to the main objective, the ducks. Right now, hitting them just turns the debug box red. We need gravity. I stitched together the shocked frame and the vertical forwarding frames. The logic is simple state switch. When a hit is confirmed, the duck stops moving. We switch the sprite to the forwarding animation and apply a positive Y velocity. It drops until it hits the bottom of the screen, then we reset it. It's not Doom without the Doom guy himself watching you from the bottom bar. The original game had an incredibly complex system for his reactions. He would breathe, grit his teeth, look surprised. I'm not doing any of that. I just grabbed a simple idle loop where he looks around. I added a movement vector directly into our animated sprite struct. This cleans up the main loop significantly. Now, the physics are tied to the object, not floating around as loose variables. This handles our dead duck logic perfectly. It cycles through the shocked frames and then transitions into the forwarding loop, dragging the Y position down every update. For the Doom guy, I position him at the dead center where he belongs. I gave him a very slow frame time of 1 second. This creates that low frame rate idle animation where he looks left, right, and center. We need to nail the death sequence: the shock, the pose, and the drop. The easiest way to handle this in my framework is to split the assets. I created specific sprite objects for each sequence. It might be different for you depending on your tech stack, but for me, this is the cleanest way to deal with it. When the bullet connects, we disable the flying duck and immediately render another one in its place. It's classic asset swap again. I set up a simple state machine with 3 phases: flying, getting hit, and forwarding. Inside the onUser update loop, we use a switch statement to control the show. Flying, for flying, the duck moves normally. For getting hit, if we land the shot, we switch to this state. We play the shocked animation, and the moment that animation finishes, it automatically flips the state to forwarding. We swap the sprite to that version, which is duck S1, which has a positive Y velocity. Quick refactor. I swapped all position and movement vectors to float. I didn't want to clutter the code with another movement timer just to slow the duck down. With floats, we can increment the position by tiny fractions like 0.3 every frame. The computer accumulates those fractions and the objects move slowly at subpixel speed. So gravity takes the wheel and the duck drops off the screen. Well, not quite. 2 weird things happen. The duck hits the floor and bounces like a rubber ball, and the Doom guy has mysteriously levitated up the screen. Why? Because our engine outsmarted us. Remember that boundary logic. It forces every sprite to stay inside a specific pixel play area. It sees the dead duck hitting the floor and says, bounce. It sees Doom guy sitting in the UI area too low and says, you are out of bounds, get back up there. We need to polish that logic. I added a move flag to our draw function. This solves the floating Doom guy bug. By passing false for the Doom guy and the hat, the engine knows to ignore the boundary logic for them. He stays anchored to the UI. But for the duck, we pass through. It flies, it bounces off the walls, and when we shoot it, it falls, hits the grass, and reset the loop. I just changed its state to spawning a new one before it hits the floor. It's still not perfect, but we are on the right path. I also split shotgun into 2 separate files, gun 0 for the idle and gun 1 for firing, just to make the specific animation tied to specific sprite sheet. Right now, our duck is predictable. It spawns in the same spot and flies at the same speed. It's basically a target practice dummy. To turn this into a game, we need chaos. I included a random library and set the Messner Twister engine. If you are still using rand, stop it. Get some help. Something like my video about distributions. I created a new spawn duck function. Now when a duck spawns, it picks a random start position along the bottom. It flips a coin to the side, left or right. It picks a random speed and trajectory. It also updated the state machine. When a duck falls off the bottom of the screen, the state switches to waiting, which immediately triggers spawn duck and reset the loop. Time to handle success and failure. If we miss 3 times, the duck needs to fly away to mock our aim. I added fly away animation for that. But if we hit, we need a reward. I'm adding the animation of the dog holding the capture duck, Seeing him like this. Maybe he isn't that bad after all. He's just a hunting dog, doing his job. When we succeed, he's right there celebrating with us. To manage this, I'm giving the dog his own states. He monitors the duck's status. If the duck escapes, he transitions to the fail state. If the duck drops, he transitions to the success state to present the trophy. He's only a villain if you miss. I added a bullets counter and initialized to 3. Every time you click, it drops. Now we have 2 branching paths. Failure. If you run out of ammo, the game triggers the escaping state. The duck flies straight up and the dog transitions to fail. He pops up and laughs. Success. If you hit the duck, it falls. Once it hits the ground, the dog transitions to dog state success. He pops up holding the duck, celebrating your victory. I also hooked up the HUD display to the actual ammo count using STD2 string for bullets. Now, the Doom interface actually gives you tactical information. It's still a little wonky, but it's starting to look real. We need to fix few things and add actual endgame. What happens if you ignore the ducks and get the dog? It's not right decision. So I'm not going to throw up confetti or congratulations. In fact, I'm not going to render any text at all. Anything. Just a big blank nothing. The game loop effectively stops. The ducks stop spawning. It's just you and the consequences of your actions. However, I think one person would appreciate this. He doesn't say a word, he just smiles. And honestly, that's all the closure we need. I cannot give you the full project files with the sprites included, because these assets belong to Nintendo and its software, and I would very much like to keep this channel alive. However, you can follow along, use any assets you want, and build something even better. If you get stuck or need help, join the Discord, the link is in the description. And a little sneak peek for the future. The Doom footage you saw, that wasn't the video file, that was the game running inside Visual Studio. If you want to see more, don't forget to subscribe. Thanks for watching, and ciao!